My name is Tarek, and in today's lecture, we will implement the delete operation for the binary search tree. In the last lecture, we saw the insertion operation of the binary search tree, and we thoroughly went through the flow of code for implementing the insertion operation. So for delete operation, we have three cases. The first one is deleting a leaf node, and the second one is deleting a node which has one child, and the third and the last case is we have delete a node which has two or more children. So right now for this video we will concentrate and I'll show you the first case, deleting a leaf node. So let me remove these two cases for now. Okay, so I have a demo structure here. I have a demo structure of a tree, a binary search tree, and I also have some code already written for your understanding. I'll walk through this code for you, and then we will write some additional code. This is not the complete code for this case. We will write some additional code also, and then we will complete the implementation of the first case. So let's start now, and first we will have to call this delete method. So we will say pst.delete. Now which node we want to delete? Let's say for the first case we have 10, 22 and 100. These are the leaf nodes, and let's say I want to delete 22. Okay, so I will say 22, right? And let's start this program in the debug mode, right? And right click and debug file. So now I am here. So now I am at the first line. Let me do in the first line of the code. So the code says the node parent is equal to root and the current is equal to root. So both the pointers we are setting them to the root node. So root is actually here. The root node is actually pointing to the root node. The root pointer is pointing to the root node. Now the parent and current both are pointing to the root node. Both pointers are pointing to the root node. Okay, now I have this boolean variable is left child equals to false. How this will be helpful, I will let you know. Let's run this code, and then you will automatically come to know why this boolean variable is important. So let's say I have is left child, and now this where the value of this variable is false. So I'm setting this to false right now. Okay, so the next line is current dot data is not equal to id. So id is equal to 22, right? And what is current? Current is 50. So this condition is true now. So unless we have the current dot data is equals to id, this loop will run. So actually what we are doing, we want to get to the node that we want to delete. We will have to start from the root node, and then we will traverse through this binary search tree, and we will get to the 22 node, the node which has the data 22. Only then we can delete that node. So with these pointers we will get to 22 node. Okay, so next step is parent is equals to current. So parent and current both are pointing to the same node. Okay, the current dot data is greater than id. So is 50 greater than 22? Yes, 50 is greater than 22. So it says left child is equals to true. So let me set this to true. Okay, left child is equal to true, and current dot left is equals to current. Now we are setting its left. So the left of current is 30. So now it's pointing to 30. Okay, and current is equals to null. No, current is not equals to null right now. So now current dot data is 50 is equals to 22. Sorry, now the current is 30. Sorry, Now current is 30. So current 30 is not equals to 22. It's true. It's not equals to 22. Now parent is equals to current. So parent will move from here to the current, right? And now current dot data is 30. 30 is greater than 22. Yes, 30 is greater than 22. So we will set is left child equals to true. So it's already true. And what we are doing is current dot left is equals to current. So it will go to the left hand side, and the left hand side is this one, right? Okay. So current is equals to null. No, it's not null. Okay. Current dot data is not equals to id. So 20 is not equals to 22. This is correct, right? It will come down. Now parent is equals to 22. So now parent will also get the reference of the current. Now current dot data is greater than 22. So 20 is not greater than 22, right? 20 is not greater than 22. So now it will come in this block, else block, s block. Now is left child equals to false. We will have to set the is left child. Okay, so we will set this to false. Okay. And now current dot right will be set into the current, right? So whatever is on the right hand side, that will be set to the current. So this node's right hand side is 22. So now this node, the current pointer is pointing towards the node 22. Okay. So it's not equals to current is not equals to null. Okay. Now current dot data is equals to id. I think it's equals to id. It is 22. id is 22, and current is also pointing to 22. So up till now, what we got, we have reached to the node which we want to delete. Now what we want to do, we want to further check a few of the rules to completely delete this node. Okay, so we will actually have to write some additional code to make this operation, to make the first case complete. And what we will say, so we will say if current dot left is equals to null, right? Now what we are checking is this node is actually the last node or not, right? Because we have got to the node which we want to delete. So user wants to delete node number 22. We have reached at node number 22. Now we want to check, is this the leaf node or not? So we are adding those checking now, and we will say current dot right is equals to null. Okay. So now now we are checking if current dot left is equals to null and current dot right is equals to null. So left and right nodes of this node should be null because it's the leaf node. And if it is true, then further check current is equals to root. And if it's equals to root, so set root equals to null, right? Set the root node equals to null. Else if otherwise is, now we will use the boolean variable that we declared in our code. So we will check is left child is equals to true, right? Because if it is the left child, now what we would do then, we will do parent dot left set to null. If left child is equals to true, then parent dot left set to null. Otherwise else what should you set to null? Now it's very obvious for you. Parent dot right set to null. Okay, so this variable is very helpful in determining which node we want to set to null, right? So with this variable, we know that is this the right node we want to set null, or is this the left node we want to set null. Okay, now our code is complete, and now okay, let me stop this. And now this was false. Now what I can do is I can say here, I can say return true, right? And now we have already gone through the first part, so we will directly jump to the second part, and let's start in the debug mode. So now here, so now let's see the value of current dot left. If we check the value of current dot left, it's equals to null, right? And where the current is standing, the current is standing at 22, right? It is 22. And current dot right is also equals to null, so it will come here. Okay, so current is equals to root. No, it's not equals to root. Current is actually 22. So we'll come here. Is left child equals to true? No, left child is not equals to true, because this is on the right hand side. This is parent and this is the right hand side, right? So it will come here and here. Parent dot right equals to null. And when we will execute this line, now we do not have this node. So this node has been, so we do not have any node on the right hand side now, and now we are returning null. So this is the demonstration. This is how the first case we have implemented, and I think this will be very helpful for you. In the next video we will see how to delete a node having a single child.